Now I'll be looking at the earth as a sphere, longitudes and latitudes. And I should mention that rarely would you find question in regards to this in JAMB. So if you are just trying to learn the important topics, you can choose to skip this. But if you just want to know this topic for the purpose of WAEC, or you have a lot of time to spare, then you can go through this topic. So the earth. So the earth is, as you can see, this is a picture of the earth, and as you can see on the earth, there are very many rough patches on the earth. You have mountains and different other features. So the shape of the earth is usually referred to as geoid, Geoid. But because we want to simplify our calculations, we approximate that the earth is spherical in shape, and the diameter of the earth is about 12,800 kilometers. So we're going to be talking about how to calculate the distances between points on the earth's surface. So let's start with looking at the great circle. So the great circle divides the globe in half. The equator is the special great circle that runs from west to east. So just think about the earth as an orange. So any line that divides the orange into half is referred to as the great circle. So you can decide to divide the orange horizontally like this. So this is a great circle. You can decide to divide it like this. This is also a great circle. You can decide to divide it like this. This is also a great circle. Provided you are dividing it into two equal halves, then that line is referred to as a great circle. So in your cardinal points now, you have your north at the top, then south at the bottom, and you have west at the left and east at the right. So the line that runs from west to east divides the earth into two equal halves, and is a special kind of great circle that we call the equator. So this is the equator over here, the line that runs from the west to the east. So let's talk about longitudes. So longitudes are lines that run from the north to south. As you can see, all these lines that have been drawn here are what parallels of longitude, and they run from the north to the south. So how do we measure them? We measure our coordinates in degree. So this center point here, as you can see, this vertical line over here, we call it 0 degree. So when you start moving towards the left in this direction, then this first line represents was 10 degrees, and I'm moving towards the western direction. So this is 10 degree west, 20 degree west, then here will be like say 70 degree west. And when you're moving towards the direction, this will be like 0 degree east, it will be like your 10 degree east, then here will be like your 60 degree east. Then that is when you're moving towards the direction. So you start your 0 degree from the vertical line that runs from the north to the south. So now look at how to locate longitudes. So draw the following lines of longitudes. So the first thing we want to do is we want to sketch out our globe. And when we do that, we have the north here, then we have the south here, then you have west, and you have your east over here. Then draw your vertical line that runs from north to south, and that down from west to east. So the first point we want to locate is 30 degrees west. So now, as I mentioned, the lines of longitude runs from the north to the south. But now that I'm moving towards 30 degree west, then I'm moving towards this direction. So that will be somewhere around here. So this section or this line represents what? 30 degree west. How about 70 degree west? Now since this is 0 degrees in the center here, and this is 30, 70 degree west will lie towards the back. So 70 degree west will be somewhere here. So this is 70 degree west. Then what about 20 degree east? Now the east is towards this direction, the right direction, and 20 is closer to 0, to be closer to this vertical line. So 20 degree east is given as the orange line. So this is 20 degree east. How about 50 degree east? To be at the back of 20 degree east, and that will be somewhere around here. So this is 50 degree east. So now let's talk about latitudes. So as we've described before, longitudes run from the north to south vertically, while latitudes are the lines that run horizontally. So the way we measure this, or the way we look at it, is from the great circle that we have at the equator. So the line that divides the earth equally from the west to the east is referred to as the equator. So when we move upwards, we are moving towards the northern direction. So this first line over here is what, 10, then you have 20, 30 degree till you get to the top, which is 90 degree. And when you move downwards, you are moving towards the southern direction. Then here is 0, 10, 20, 30 down. So I'm going to draw some points so that you can know how to locate latitudes. So let's draw the following parallel of latitudes. So the first thing we want to do is to first draw our globe as usual. So we sketch out the globe. And we have our north, our south, then our west and our east. We have a line running vertically down here. And the first point we want to locate is 20 degrees north. So 20 degrees north now is going to be closer to the equator. So I'm going to have a line running in this direction like this towards the northern half. So this is what, 20 degree north. What about 50 degrees north? 50 degrees north is going to be higher because here represents 0 and 50 is above 20, so it's going to be higher here. So at this point over here, I have what, my 50 degrees north. What about my 20 degrees south? My 20 degrees south is going to lie closer to the equator but towards the southern direction. So it's going to be somewhere here. So this line over here represents my 20 degrees south. And what about my 80 degrees south? That is going to come down towards the southern hemisphere. So I have my 80 degrees south over there. So this represents what, my 80 degrees south. So now we're going to be looking at how to locate points on the globe. So locating points is based on the coordinates that are given. So the coordinates that are given, we are given the latitude coordinate and the longitude coordinate. So what we do is that we try to draw those lines out, and the point of intersection is the point of interest. So now here we are told to locate these 4 points: point M, point P, point Q and point R. So let's get started. First thing we want to do is we want to draw out our globe as usual. So we draw out the earth and we label our coordinates. We have north here, we have south, we have our west and we have our east. So the first point we want to locate says that point M is at 35 degrees south. So we look for 35 degrees south. 35 degrees south is going to lie towards the direction. So we have 35 degrees south. So this is what, 35 degrees south and 55 degrees west. West is in this direction, so 55 degrees west is going to lie in this direction. So this is what, 55 degrees west. So the point of intersection of the line of longitude and the parallel of latitude, this point over here, is point M. Now the second point tells us that we have our P at 60 degrees north. So I'm going to draw that with a different color. So we have 60 degrees north, and that is going to be in this northern hemisphere over here. So this is what, 60 degrees north, and what, 55 degrees west. And 55 degrees west is still this red line that I have over here. So the point of intersection of this line and that line over here, this point over here, is what, point P. So now let's look at another example. We are told to locate points Q and R. So the first thing you want to do is you want to sketch out the globe. Now when you do that, you label your coordinates north, south, west and east. Sketch it down like this. So now I'm told that the first point is 60 degrees north. So 60 degrees north is going to lie above here. So I have my 60 degrees north over here. And what? Second point is at 20 degrees east. So 20 degrees east is going to be along this side over here. So here I have what? 20 degrees east. And the point of intersection of those two lines is my point Q. Now the second point, I have 35 degrees south. Now 35 degrees south is going to be in this direction over here. So I have 35 degrees south over here. 35 degrees south. This point over here is what? 35 degrees south, and 20 degrees east, which is this line already. So the point of intersection of those 2 points is what? Is my point R, or my location R. So now let's look at calculating angles between 2 points. So here now we are told to find the angle between these 2 points. So the first thing we want to do is we want to locate those 2 points. So we sketch out our globe and we label our coordinates. We have north and we have south here, and we have west and we have east over here. So we just sketch it. And for the first part, we are told that we have 35 degrees south and 55 degrees west. So 35 degrees south will be towards this direction, towards the southern hemisphere. So I have 35 degrees south. I have 55 degrees west, which will be towards this western side. So I have what? 55 degrees west, 55 degrees west. So this point over here is point M. Now we are told that for point P we have 60 degrees north, which will be upwards here. So here we have what? 60 degrees north, and it still lies on 55 degrees west, and this is 55 degrees west. So the point of intersection is what? Point P. So now if you look at it carefully, our distance now, we want to try to calculate the distance between point P and point M. And what we do is that we draw that line towards the center. And when we draw that line towards the center, we can see that we have something sort of like a sector. And in that sector, we are supposed to have an angle over here, so that we can use the formula for the length of an arc to calculate the distance between P and M. But the angle over here for this P now, we are told that is 60 degrees north. So the angle over here is what? 60 degrees. And the angle towards the southern side, or the west southern side, is given as what? That is given as 35 degrees. So the distance, the angle here is 35 degrees. So what will be the total angle? The total angle will just be the sum of these two angles. So we have 60 plus 35, and that gives us 95. So the total angle is 95 degrees. Now let's look at another example. So first we'll try to locate those points. Label our coordinates. We have north, south, we have our west and our east. So we just indicate that. And for the first point, we have 60 degrees north. So 60 degrees north will lie here. And we have what? 20 degrees east. And 20 degrees east will lie towards the side. So here I'm going to have my 20 degrees east. And it's going to be very close here. So here I have what? 20 degrees east. So this point of intersection is my point Q. For my point R, I have 35 degrees north. So my 35 degrees north is going to lie below this, so in the same direction. And 20 degrees east, which is on still the same line. So the point of intersection with this point is my point R. So now I want to, so the thing I want to do now is I want to connect those 2 points to the center. And when I connect it to the center, I have like a sector. Now I'm told that the angle between this first line over here and this center is what? 60 degrees. I'm going to label it here 60 degrees. And I'm told that it's now from my point R to this center is what? Is 35 degrees. So now that I've gotten that, question is now, what is the distance or the angle distance between this point Q and R? So since from here to here is 65 and from here to here is 35, this smaller portion here will just be 60 minus 35, and that gives me 25 degrees. So the summary or the point I want to make is that when you are calculating distances between 2 points, and the 2 points you are calculating, they are in different hemisphere. Like for example, one of those points B is in the northern hemisphere and one is in the southern hemisphere. What do? You add their angles together. So in this case, look for the non-equal angle here. So you have 35 degrees south here and you have 60 degrees north here. So what do? You add them together. So 60 plus 35 will give you 95. On the other hand, if they are in the same hemisphere, for example, you have 60 degree north is in northern hemisphere and 35 degrees north both on the northern hemisphere. To get the angle between them, you subtract the coordinates. So you have 60 minus 35 and that gives me 25 degrees. Okay, so let's look at some more examples. So here we are trying to find the angle between these 2 points. So the first thing we want to do is we want to sketch out our globe. So I have something of this sort. And we label our coordinates. We have our north and our south, our west and east, and please don't mind my diagram. So for the first part, you have 40 degrees south. So 40 degrees south to be towards this point over here, 40 degrees south, and 25 degrees west. 25 degrees west to be towards the direction over here. So you have what? 25 degrees west. For the second one, you have 20 degrees south, which is also this line over here. And so this point over here is my point M. And for my second point, you have 40 degrees south, which is also this line, and 55 degrees west. So 55 degrees west will be at the back of this, which will be at the back of this point over here. So this is what? 55 degrees west. So as you can see, this point here is point P. As you can see, these 2 points lie in the western hemisphere, in the western half. So what can we say about their angle? Their angle will just be what? The angle will just be the difference between their coordinates. So the angle theta here now will just be what? 55 minus 25. And what does that give us? 55 minus 25 is 30. So the angle between two of them is what? 30 degrees. Now let's look at the last example. So the first we want to do is we want to sketch out our globe. And once we've done that, we label our coordinates. And the first point Q tells us that Q is what? 30 degrees north and 20 degrees east. So at 30 degrees north, be about here. So I have what? My 30 degrees north. And my 20 degrees east to be around here. So I have what? My 30 degrees east, or my 20 degrees east rather. So the point of intersection is my point Q. For my point R, I have 30 degrees north, which is this line over here. But now I have 40 degrees west, and that will lie on the other part here. So I have what? This part over here, which is my 40 degrees west. So the point of intersection is my point R. So now I have to calculate the angle between these 2 points. So if I trace that out towards the center over here, I will have something of this sort. And now I can see that one of those points lies towards the west and one of those points lies towards the east. So what will be my angle between those 2 points? I'm just going to sum up those angles. So it's just going to be what? The one in my west, which is 40, plus the one towards my east, which is what? 20. So 40 plus 20 gives me what? 60 degrees. So the angle between these 2 points is what? 60 degrees here. So one thing you will realize that when you are giving coordinates, one of those coordinates will be equal. As you can see, you have 40 degrees south here, 40 degrees south here. Here you have 30 degrees north and 30 degrees north. The angle that we are adding or subtracting are those angles that are not equal. As you can see, in this case, we subtracted 25 plus 55, and in this case, we added 40 and 30. So look at the coordinates and 20 that are not equal. So let's talk about calculating distance along the great circle. So now, as we've talked before, great circle are lines that divide the earth into 2 equal halves. So how do we calculate distance between them? So let's imagine this is a great circle over here. I want to calculate the distance between points P and Q. Now, if this is the center, I can draw a line or 2 lines towards the center. And what would that be? A line drawn from the center of a circle towards the body touching a sphere, or towards the circumference of a sphere, towards the surface of a sphere, is referred to as the radius. So this line here is a radius, and this line here is also radius, and this is in this case the radius of the earth. So if I bring that part out, I have something of this sort. I have my point P and I have my point Q, and I have here as radius. So now what is the formula for calculating distance of an arc? Because this is an arc, as you can see, point P and Q is an arc. The distance is what? Theta over 30 times 2 pi r. But in this case now, r is the radius of the earth, and the radius of the earth is given as 6,400 kilometers. So you have to know that. So when you have distances along great cycles, what you do is to calculate distance, which is theta over 360 times 2 pi r, where r is the radius of the earth. So let's look at some examples. In this first example, we are told that the positions of Libreville and Kampala are this and this respectively. Calculate their distance apart. So the first thing we want to do is we want to sketch out on our globe. So when we sketch out those positions, we will have our north, south, west, and our east. Well, sketching it out is not really compulsory. So we are told that the first point, Libreville, is at 0 degree north and 9 degrees east. So we know that 0 degree north now is going to lie at this center part here. So this point lies in the equator. So I have my what? My 0 degrees north and 9 degree east. So east is towards this direction. So I'm going to have my what? 9 degrees east. So this is 9 degrees east. And the point of intersection is Libreville, which I will denote as L. Now for Kampala, I'm told that the coordinate is 0 degree north, which is also this line over here, and 32 degrees east. So since in the eastern hemisphere, it's going to be at the back of this 9 degrees east. So Libreville is going to be at the back over here. And the coordinates over there is what? 32 degrees east. So the point of intersection over here is what? Kampala. So I now find the distance between these 2 points over here. So as we said, the formula for calculating the distance is given as theta over 360 times 2 pi big R. Now the reason why we are using the big R here is because I'm calculating along the equator, and if you remember, the equator is also a great cycle because it divides the earth into 2 equal halves. So now if you look at these 2 points L and K, you can see that they both lie in the eastern hemisphere. They both lie towards the east. So what do we do about their angle? So their angle theta is going to be the difference between them. So the theta is going to be what? Theta in this case is going to be 32 minus 9, and that gives us 23 degrees. So the angle between these 2 points are 32 degrees. So my distance is just going to be 23 over 360 times 2 times, I'll use pi as 22 over 7, and the radius of the earth is 6,400 kilometers. And the distance is going to be, if you punch your calculator, 2,570.15 kilometers. So the distance between Libreville and Kampala is 2,570 kilometers. Now let's look at one more example along the great cycle. So now I told that Sidi Barani and Gaborone both lies on longitude 25.9 degree east. So first we want to sketch that out. So we draw out our globe, and drawing out the globe is not compulsory. I'm just doing it so that you can visualize it. You can still attempt those questions without drawing it out. So you have what? Your north and your south and your west and your east. Now you are told that both of those points lies where? On the longitude of 25.9 degree east, and 25.9 degree east is going to be around here. So I have line coming over towards my eastern direction, and this point over here is my 25.9 degrees east. Now their latitudes are 31.6 degree north. So the latitude of Sidi Barani is 31.6 degree north, and that will be what? So 31.6 degree north will be towards the north, and that will be above here. So I have what? 31.6 degree north. So the point of intersection is Sidi Barani, this point over here, and Gaborone is 24.8 degrees south. So Gaborone is 24.8 degrees south, and south lies downwards, so it's going to be towards this point over here. And what is that point? So 24.8 degrees south, and the point of intersection of the line with the line of latitude is my what? Gaborone. So this is my point Gaborone. So now I'm told to find the distance between these 2 points. So I'm looking for the distance between this point and this point along this line. Since they are along my line of longitudes rather, I know that I can apply that formula because all lines of longitudes are lines along the great circle. So my distance now is going to be what? Theta over 360 times 2 pi r. Now theta in this case is going to be what? The summation of these two coordinates. And why is that? Because CD Barani lies in the northern hemisphere while Gaborone lies in the southern hemisphere, and since they lie in different hemispheres, what I do to their angle is that I sum them up. So theta will be 31.6 plus 24.8, and that gives me 56.4. So the distance between those 2 points is what? 56.4 divided by 360, then times 2 times 22/7 times 6,400, which is the radius of the earth, and that gives me what? 6,302.5 kilometers. So the distance between Sidi Barani and Gaborone is 6,302.5 kilometers. Now let's look at how we calculate distances along the parallels of latitude. So sometimes you want to calculate distances along lines that are not great cycle. And not great cycle means they don't divide the globe into two equal halves. In longitudes, the radius was constant because we were dividing. This is supposed to be dividing, so there's a typo here. We're dividing the earth in half. Now that's not the case. So yeah, if you remember when we are calculating distances along the power of latitude, for example, look at this latitude over here. So for a quick sketch, imagine I have the earth over here now, and I have a line of latitude over here. As you can see, this division over here does not divide the earth into two equal halves. Here the bottom is bigger than the top, so the radius at this point is not up to the radius of the earth, because this point is not at the center of the earth. It's smaller. So when I'm calculating parallel along the lines of latitude, the radius of the earth is not a constant value because it varies based on the location, and we have to calculate how it varies. So getting the angle, we already know how to determine the angle. If the points you are locating lies in different hemispheres, we just sum of the theta. But how do we now calculate the radius? So now to explain or to illustrate that point, the way we do that is, for example, now let's assume that this is our point over here. So I'm going to sketch that out over here. So this small point now, let's try to calculate. Let's call the radius of this small point here r, and the radius of the earth big R. I'm going to draw that down. So if I draw a line from here to here, I'm going to call this place alpha, and alpha here represents what? It represents the coordinates of latitude. So when I get that alpha, so I can draw that out. So I have a triangle in which I know that this point also from here to here, since from the center of the sphere to what is circumference, I know that this point also is the radius. So I have the radius here. I have this angle alpha here, which is the latitude, and I have a small r. So cos alpha now is equal to the adjacent, which is small r, over big R, which is the radius of the earth. So small r is equal to what? R cos alpha. So when I'm calculating the distance now, distance is going to be theta over 360. The distance now is going to be theta over 360 times 2 pi small r. But in this case, this small r now is given as big R cos alpha. So it's going to be theta over 360 times 2 pi big R cos alpha, where r is R cos alpha, and where alpha is the latitude coordinate. So this next example will illustrate what I mean. So here I thought to find the distance measured along the parallel of latitudes between 2 points whose latitude are both 56 degree north, and whose longitude are 23 degree east and 17 degree west respectively. So as usual, the first one to do is one try to sketch out our problem. So when we sketch it out, we have our north, we have our south, we have our west, and we have our east. So when we thought that both of them lies were both on what? 56 degrees north. So both of them lie in this position. So this is 56 degrees north over here. So I'm going to call this what? 56 degrees north. Now the first point is what? 23 degrees east. So the first point that is 23 degrees east is towards this direction. So the first point is along this point over here, and it's given as what? 23 degrees east. And the point of intersection with my latitude is my first point, and let me call that 1. Now for my second point, I'm told that it lies in 70 degrees west. So it's another hemisphere, and it lies 70 degrees west. So that will be one more closer. and this is going to be my 70 degrees west. So the point of intersection with the latitude is my point 2. So now I want to find the distance. So if I trace from that point to the center, I can see that the radius here is going to be far smaller than the radius of the circle. So since this is along the line of latitude, I'll make use of the formula that says that what my distance is equal to theta over 360 times 2 pi bigger cos alpha. Now what is theta? Theta is the angle between this point 1 and 2. Now I can see that one of that point lies in the east while the other lies in the west. So what do I do to find the angle? I just sum up the coordinates on the east and west. So the theta in this case is going to be what? 23 plus 17, and that gives you 40 degrees. So what about alpha? Now alpha is just my latitude, and in this case the latitude is given as 56. So my alpha is 56 degrees. So to find the distance, I also substitute the value. So I have 40 over 360 times 2 times 22 over 7, then times bigger with 6,400, then times cos 56. And when I punch this into my calculator, what I get is 2499.5 kilometers. So that is the answer. So the distance between the 2 points 1 and 2 is 2499.5 kilometers. So the first thing to recap, the first thing we did was we sketched it out, and since those 2 points lie on different hemispheres, to get the value of theta we just sum their coordinates. And we have said that alpha, and since they both lie along the lines of latitude, so we have to make use of this other formula where we have r cos alpha instead of only r. And we said alpha is the latitude, and the latitude in this case is given to be 56 degrees. So we have alpha to be 56, and when we substitute it in the formula, we get our distance between these 2 points to be 2499.5 kilometers. So now let's move on to the last example we'll be looking at. So here we are told to find the parallel of latitude in the northern hemisphere. This is a typo here. This is supposed to be northern hemisphere, along which a journey of 640 kilometers makes a change of 8 degrees in longitude. So now we're trying to find the latitude. So try by drawing a sketch. So we have our north and our south, and we have our west and our east. So we're told that this point lies in the northern hemisphere, so it lies somewhere here. But the coordinates or the latitude we do not know. We do not know the values, and that is what alpha. Now we told that there are 2 points along this line of latitude. It's just arbitrary. I'll just name it 1 and 2. In which the angle between them is what? Is 8 degrees. So I thought that the angle between them is 8 degrees, and the distance from 1 and 2 is 640 kilometers. Now we're not told to find the value of alpha or the latitude. So we know that our distance is what? Theta over 360 times 2 pi r cos alpha. So my distance has been given to be 640. My theta has been given to be 8 because I'm giving the change, so which has already been added or subtracted. So I have 8 over 360, then times 2 times 22 over 7 times 6,400 times cos alpha. And what does that become? So if I make cos alpha as a rate of formula, so I have cos alpha is equal to 640 times 360 times 7 all over 8 times 2 times 22 times 6,400. And when I punch this into my calculator, I have cos alpha to be equals to 0.7159, and my alpha will just be the cos inverse or arc cos of 0.7159, and that is equals to 44.3 degrees. So now since I'm told that this line of latitude lie in the northern hemisphere, I know that my coordinate is just going to be 44.3 degrees and northern hemisphere north. So that means that the coordinates of my latitude is what? 44.3 degrees north. So this pretty much sums up the idea of latitude and longitude. And if you want to practice more, you can go through the textbook or your textbook and find more questions that are relating. But as I've mentioned before, JAMB do not really set questions that have to do with longitude and latitude. But this is really important if you are planning to take the WAEC or if you would like to know it. So that pretty much sums up our discussion on longitude and latitude. Bye.